if we talk about the AI, so the definition of this AI was actually coined in 1950 or 60s, the capability of machine to imitate intelligent human behavior. So we are going to make the machine that it will treat like a human behavior. So there are, what is the relation between AI, machine learning and deep learning? So we can say the machine learning is a subset, or we can say the technique by which we are going to achieve some AI to our systems. Okay. And further, we have this deep learning. Deep learning is also a subset of your machine learning. So we are going to see that what is the difference and when you will use the machine learning or deep learning for your applications area. So we have different type of toolboxes are available if you want to build your AI type of application with the MATLAB. Like we have the machine learning toolbox, deep learning toolbox, and third type of machine learning is called, this is called reinforcement learning. Okay, so today we will not cover this reinforcement learning, but generally it is used where some on the basis of some policy we train some systems. Okay. Then if you want to use MATLAB and Simulink for your predictive maintenance, suppose you want to just find out that how much part or we can say the particular machine when is going to under maintenance. So we can just based on the historical data of that particular machine, we can build some type of predictive model so that we can know in advance that how that particular machine is going to under maintenance. Then within this, we have the functionality that we can use the toolboxes, MATLAB, other toolboxes for data science and data analytics. So generally, if we talk about the AI and data science and statistics, we have these toolboxes like deep learning toolbox, static machine learning toolbox, curve fitting toolbox, and if somebody want to work on tax data, so we have the tax analytic toolbox also available for that. Okay, so generally just you are able to hear some workflow, that what workflow you are going to just follow, that if you are going to build your AI type of application. So what is the first step? That data preparation. So maybe that if you are going, you have some type of data, so you are going to first import that data into MATLAB or other software. And if your data is not ready, that you are going to devote much time on this data preparation. So that we will see that what are the functionality available, that how quickly and interactively you can just prepare your data for this type of AI type of applications. Once your data is ready, that we have this option that AI modeling. So we will develop some AI model depending on our data. Then as if you require, the system design is available. And finally, if you want to deploy your data or your model onto the hardware, so we can just directly generate the code from that particular AI model to deployment on the hardware, so that particular model can work onto my hardware. So machine learning applications. So machine learning are everywhere, that in varieties of applications we can use it like for speech recognition. So if you want to just recognize the different type of speech, so depending on our audio, so if you want to just build this type of model according to your applications area also. So different type of machine, how the sound, that particular machine, different type of sound are creating. So we can build this type of just applications area for our domain also. For object recognitions, if you want to find out some particular vehicle or some particular object, for example, for your applications area, you want to find out some particular object, so we can just build this type of applications area. Then engine, I think it is in white color. So, but this engine health monitoring system. So further, again, if you have the data with you related to your machine or some electrical parts or electrical machines, so based on that data, what we can do, we can just build the AI model with the help of that data, and we can use it for prediction purpose. We can use it for weather forecasting, energy load forecasting. So depending on your some historical data, suppose you collected some data from the online website, and you prepare some data. So based on that data, you can also build some type of machine learning models for energy load forecasting. And so that you in advance, you can just predict that what actually power will require in particular area in particular day, or if there is some holiday, or there is some festival. So in advance, you can just predict that how much power will be required in particular area at particular time. Further, we can use this application for stock market predictions, for IoT analytics also. So if you want to just apply this your AI type of application for IoT analytics, taxi availability, that if you know that based on the historical data, you can just build some type of model so that you can find out that how many maybe Uber or a particular vehicle is available like near the airport at particular time. Further, we have this airline flight delay. So this type of applications, we can generally use this type of machine learning. So here what we can do, that learn complex non-linear relationships. So machine learning algorithm learns complex data from non-linear relationships. If you are working on this type of data, suppose your data is changed or some historical data is changed. So you can update these type of machine learning models as your data is updated, so that you can just predict more accurately from your machine learning models. And if you are working on very large data sets, so in this type of application, as you know, in each second there are a lot of data is generating here. So efficiently we can apply these type of machine learning algorithm on very large data sets also. So if someone is new for the machine learning, so this is the definition of machine learning, that machine learning teaches computer, okay, to do what comes naturally to humans and animals. Like you are aware that how the humans learns. We generally learns from the experience. When we are kid, that we are just learning from our parents. So like this also, machine learning algorithm or machine learning models directly learns from data without relying on any mathematical equations. So we will see that depending on your data type or what are the data you have. So once we are going to train that particular machine learning model, so depending on my data, it find out, we generally pass some features to build my AI models. So depending on that one, that particular algorithm directly learns from that particular data. Okay. So these algorithms are adaptively improve their performance as number of samples available for learning increase. So if you have sufficient data, so we can just use to build your machine learning models. So now just see the difference in machine learning versus deep learning. So deep learning, as you aware that there is a one subject or technology, this is called the neural network. Okay, so neural network, it works like our neurons. Okay, so artificial neural network, its work like our neurons work. Okay, so there are some nodes are available. So what is the difference? First, what is the difference in neural network and deep learning? In neural network, basically we have some limited number of layers are available. Okay, so maybe 2, 3, or 5 layers are available, hidden layers are available. But in the deep learning, the layers may be 100, more than 100 layers may be available. Okay, so here, what is meaning by deep? Deep means number of layers are more in the deep learning. So machine learning versus deep learning. So you are just able to see here two just schematic diagram of machine learning and deep learning. So here we have this machine learning model, and before that, what is we are going to feed in this machine learning model basically? So we are going to feed here manual feature extraction. So if you want to build your machine learning models, if you have the features related to your data, so during your machine learning models, you have to feed your, or you have to extract your features manually. Okay. So there are many techniques, some auto ML also available within the MATLAB that will help out. But main difference is we are going to generally passing the features to building our machine learning models. Okay, but here in the deep learning models, we generally only pass my data, but these CNN, this is called the convolution neural network. Basically, it's find out the features from my data automatically. Okay, for example, if I just pass out the some data or image data, and I want to just classify the what type of object or what type of image I am passing here. So this is my own extracted feature I will pass here, and it will classify my data as a car, that this is my car data or car images are available here. But here, if I'm going to pass my car images, different type of car images, so the feature from that images extracted by this convolution neural network. So we will discuss that how this CNN also work once we are going to in deep learning part. So more quickly, just say that what are the real world applications again for machine learning? Like we can use it for computational finance, like in the banking sector, if somebody want to make some type of machine learning model for credit scoring, algorithm trading, if you want to use for image processing and computer vision applications, like for face recognitions, motion detection, if you want to just find out the object detection, if somebody computational biology also. So in the field of medical field, we can use it for tumor detection, drug discovery, and DNA sequencing. Then further we have this computational energy production also, that we can use it for price and load forecasting in automotive, aerospace. So it is versatile. So in all the different type of applications area, we can just use this machine learning type of concept. Even that media site also believe on this one. For example, if you search something, if you are planning to purchase any mobile, for example, and you just search on the Google that I want to just purchase this Oppo or this one. So next day, it actually track your history, that what are you searching. Okay, then next day it will just give you the ad on your Facebook page or maybe on your YouTube. For example, if you are just going to listen some particular song daily on YouTube, or if you are just want to see some type of movies on YouTube also, so automatically it gives you that this song is recommended for you. So type of your flavor. So behindly there are some machine learning models are working, so that based on your historical data, they just suggest you this type of this one. Now come to the types of machine learning, that what are the different type of algorithm and what is the difference in supervised or unsupervised learning. So generally we can divide machine learning here two types. So I told you that there are maybe 3 types, but sometimes you can find out the 4 type of machine learning. One is reinforcement learning, and some semi supervised learning also available. But we will generally talk here or 2 types of machine learning. One is unsupervised and supervised learning. So what is meaning by supervised learning? For example, in supervised learning, we have our input as well as output data. Okay, so generally here in the machine learning term, input variable is called the predictive variable, and output variable is called your response variable. Okay, so if you have your predictive variables as well as your response variable, so this is the category of supervised learning. in simple word, if you know the input as well as the output, this is your supervised learning. Okay. Further, we can divide the supervised learning in two categories: classification and regression. So what is meaning by classification here? Classification means that if your response variable is a label data means suppose you have some category, like if you are talking about the bad, good, or pass, fail, or this is your some type of color. If you are talking about the voltage or current, so if your output is a label data, like you make some category that this is your low voltage, medium voltage, or high voltage. Okay, so if your response variable is a some category, so it is a part of your classifications. But if your output may be any real number, for example, if you are going to for load forecasting, so next day in particular area, maybe some kilowatt power or megawatt power is required. So that megawatt could be any number, maybe 1000 megawatt power is required. Okay, next day it could be 900 megawatt power is required. So for example, this number may be anything. So if your response variable could be any real number, so it is a category of regression here. So if somebody is new, are you getting it that what is the difference in classification and regression? Can you write in the chat? Can you write in the chat? Okay. Further, apart from this, if we talk about the unsupervised learning, so in unsupervised learning, we have some raw data. We don't have any output or input. We get some raw data. Okay. So what type of just approach we are going to use? Clustering. So we are just going to make the clustering approach. So from the raw data, we don't know how many classes there in my data. I don't know. So we are going to apply some clustering approach. So we'll talk about that. What are the different type of algorithm are available to apply for different type of machine learning. So here we have no output. Only we generally find some natural groups and pattern from the input data here. So this is the type of machine learning that, and what type of further we can divide this supervised and unsupervised learning. Now the question is that how do you decide that which algorithm will be used for your machine learning models? So there are maybe dozens of algorithms are available. Okay, so if we talk about the your supervised learning or unsupervised learning, so under the supervised we have two categories like classification, regressions. So under these classifications also we have various algorithms are available: support vector machine, discriminant analysis, neighbor, nearest neighbor, and many more algorithms are available. If we talk about the regressions, so we have again different type of algorithms are available like neural network, decision tree, and for clustering also we have the k-means approach, hierarchical approach, Gaussian mixture, neural network, or hidden Markov. So how you will decide based on your type of data, how you will decide that which type of algorithm literate and by. I need to just revise this classification and regression. So basically in classifications, we have our input as well as output is available with us. But our output is as a label data, like some categories there. But in this regressions, we have the input and output also, and our output is a maybe any real number. Okay. And in the clustering type of or unsupervised learning, we have only raw data. We have just applied some clustering type of approach. So we will just make the clusters depending on my this one. Okay. So what is the best part of actually in this type of machine learning? What we are going to just make some predictive model base our input as well as output, because in supervised learning we have input as well as we have the output also. But for unsupervised learning, we are going to discover some internal representation from input data. Okay, so we are going to just apply some type of clustering type of approach. Maybe it is k-means, hierarchical, Gaussian mixture, different type of approach are available for your unsupervised learning. So now just we are going to see that what are the workflow you are going to use if you are going to build some type of AI model. So you can use any type of software, okay, to build your AI type of model, but generally this workflow you will follow always. So what is the first step? That accessing and explore the data. So first you need to import your data into your software. If you talk about the MATLAB, so MATLAB provide you the some facility that you can import your data from different type of files. It could be if you have your data into Excel file, or if you are working some text data or different type of image data. So MATLAB provide you the option that you can import your data into different type of files. And for example, if you want to interface MATLAB with some type of database, so we have the database toolbox. So with the help of a database toolbox, we can directly just bring our data from the database also. If you want to bring some financial data from online website, okay, so we have the database data feed toolbox is available. So using the data feed toolbox, we can just bring directly our data from financial sites also. Further, third option is if you are working on some type of hardware, okay, or so hardware have the sensors. So as you are aware that we can connect different type of hardware with the MATLAB. So if you want to acquire your data from the live hardware, so it's also possible that we can import our data from live hardware or sensors also. Once you brings your data into MATLAB as a researcher, now you're done that before applying on the machine learning models, you can pre-process your data. So it may be possible that you are working on some messy data. Okay, you can just find out the features from or extract the feature from the your data or data reduction and transformation technique are available. So in the second step, basically you are going to pre-process your data. If your data have some missing values, so how you are going to handle these missing values with the help of, maybe if you are working with the MATLAB, so how MATLAB will provide you the functionality or app that easily you can just pre-process your data, or pre-process your data means that particular data finally you can use for your machine learning applications. Further, once your data is prepared, that you can just go for the predictive model. So you can just train your data to build your model, predictive models. And if that particular model is not giving you some type of high accuracy or maybe up to the mark, so what we can do, we can just apply some optimization, model validation technique, different type of model creation and machine learning toolbox as you are available. So using that, what we are going to do in the third step, basically we are going to develop some predictive models. Further, if you want to deploy, once your this machine learning model is ready, so in varieties of ways you can just convert that particular model. If you want to convert your model into some type of apps, so it's also possible that we can share that particular app to anyone, so that without installing the MATLAB, anyone can just use our that particular MATLAB model in the form of exe file. Okay. Further, what we can do, we can, if you are working on some type of other languages also, so what we can do, we can just generate different type of library or different type of code for other languages also. So like C, C++, Java, .NET. So we have the MATLAB compiler toolbox or MATLAB compiler SDK toolbox. So using that, we can convert different type of Excel add-in or the library, dynamic library of other languages also. Further, if you want to deploy your model on any specific hardware, if somebody is working on some type of electric vehicle, or somebody working for wind turbine or mobile application or aeroplane, so it also possible that from that particular MATLAB code or Simulink code, we can generate that code for our hardware also. Okay. And all the things we can do, like accessing and exploring the data, pre-process the data, developing the predictive model and deployment within the MATLAB, within the single environment. This is called MATLAB. Now we are going to see the workflow. So I've just added only the slide of this supervised learning workflow. So maybe we will see one example related to supervised, or maybe it could be your classification type, or it could be your regression type. So for example, first step, you are going to load your data, then you are going to pre-process your data. Maybe you can apply some filters, some clustering analysis, or some type of physical component analysis to reduce your dimensionality of your data. Once your data is pre-processed, that you are going to build your classification or regression model. So depending on your data, then your model is just prepared here. So you can just also visualize some type of graph from your models also. So once your model is ready, what you can do, you can just use it for prediction. Suppose you have some new data. So what you can do, suppose you have some new data. So here you have some new data, and if required, that what you can also pre-process that particular new data. Maybe your new data have some type of, again, some misvalues or something. Once your new data is ready, what you can do, what are the just model you have created within this step, your machine learning model. It could be your classification or regression. You can just provide this model, your new data, to this model, and it will provide you the prediction that what will be the output for new data. So what we are doing, we have some historical data with us. Okay. So based on the historical data, we are going to apply some machine learning on that data, and we are going to provide some features in the form of, if you talk about the unsupervised learning, so we are going to provide some input as well as output. Then we are going to train that particular model. So depending on my data, my algorithm is learning that how that particular data is behaving. If the value of that particular feature is this one, so how it is how much percent of contribution in that particular model. So once my model is ready, I can use it for predictions. So for example, maybe we can just take a different example. So let me just, it's better that I can switch to MATLAB. So what is the best part of MATLAB? That if you go to the apps, so I told you that we have already discussed this curve fitter app or some more app also. So what is the function of these apps? So without writing any line of code, what we can do, we can just solve our problem. So if we talk about the machine learning and deep learning category, so we have various apps are available here. So this is classification learner app. This is deep network designer. We will talk about that, what is basically a deep network designer app. So you can just build your deep neural network or CNN with the help of this one. Then if we talk about the machine learning, that we have this regression learner app. So if you are working on some type of regression problem, you can just use this regression learner app. If you are just working on this classification type of problem, you can just use this app to build your machine learning model. Okay. And I told you that we have the third type of or second type of category is your clustering. So if you have some raw data, so we don't have app is available, but what we have, just you are remember that we have this new script. So okay, so few year back, within this new live script, I told you that we have these tasks. So we have just shown you that how you can create plot with the help of this create plot. But apart from that, if we talk about the AI data and science, so we have this cluster data app. Within this task, it is not app, it is a task within live script. Okay, so what you can do, if you want to import your some raw data into MATLAB, we will talk about that, how you can import your data. So what we can do, without writing the code, with the help of this cluster data, what we can do, we can select our data and then we can apply different type of clustering approach. So if we have the data, we can apply some type of clustering approach. Then we can just, what we can do, we can just divide any raw data into, first we will divide 2 cluster, 3 cluster, and it will, by graphically we can just show that how many cluster may exist into my data. So the problem is that with the help of this task panel, I can solve my unsupervised type of problem. Okay, so it will provide you different method, like we have discussed the k-means, hierarchical approach, and what are the different, if you're new for this one, what we can do, what we can do, we can just visit to the doc section, doc. So I just told you that what is, how you can open the documentation of MATLAB. So in this way, you can open the documentation of MATLAB, and if you just visit to the machine learning or deep learning toolbox. So let me just here, and let me just go through to the statistics and machine learning toolbox. So this is my statistics and machine learning toolbox. So if you just click here, getting started, if you are not aware that what type of algorithm, how it works, so what we can do, we can just go here and under the documentation on this one, it will provide you the theory part also. Okay, so there may be some table, you can find out that what are the regression type of, different type of algorithm are available, or some video link also available. Okay, so through which what you can do, you can just take the help if you are some at the new stage, that how we can just use the utilize of this document also. Okay, so for this I can just use this one. So for example, okay, so in the next session we are going to just take some particular example, like using the load forecasting. So it is requested that we should just discuss and what are the different other method. But this session is general overview for AI. So I'm not recommended that you will always use this AI only for load forecasting. So further, maybe you can work on different type of problems, okay, depending on your requirement. So this is just a general overview that how you can just utilize the functionality of MATLAB to building your AI type of model. For example, what I can do, I can just take a example of, let me just show you. And if I go to in my chat, I have. So if I talk about I have the different type of data, maybe you have different type of data. For example, let me just show you one is a small example. So you can start like student performance. I have just show you this data only, and depending on this student data performance, so I have just collected this data, that this is the class test. So A, this is B, C, D. So for example, this is the class test, this is my assignment marks of student, different student, these are the attendance and any particular student, and these are the midterm marks, and these are the final marks. So this maybe these are the marks of any class, for example. Okay, so what I can do, I can just just make some type of model, machine learning model, depending on this one. Okay. So here, for example, this is my response. For example, these are the final marks of this student, and these are the final marks of this student. So what I can do, I can make some type of machine learning model based on the data, so that I can just make the category based on this one, like it is a first division, second division, or third division. So in varieties of application, I can just build this type of applications. So let me just take you another example of, for example, let me just, I have some type of vehicle data here. Let me just open it outside the MATLAB. Okay, first using this data, what we can do, we can see the what are the features are available, that how you can import different type of data into MATLAB. Okay, and how you can pre-process, what are the functionalities available to pre-process your data within the MATLAB. For example, if you want to import your data into MATLAB, so there are different type of commands are available. For example, if you want to read some XLS file, so we have the XLS read command. If you want to read some image into MATLAB, so I have the IM read command. Okay, so to read your different type of data types, we have different type of commands are available for that. So, but if you don't want to use the command, so what we have, we can import our data into MATLAB using this import data tool. So like if you are using some Excel or Word, so how you are going to import your data using this import data tool. So you can just click on import data. Okay, so let me just import some data into MATLAB, or I can import this data from. And I want to import this data, for example. Okay, so this is my data. So before importing this data finally into my workspace, it will open a import data tool for me. But what happened here? I have some missing values in my data. So maybe you will not have some data which is already prepared. Maybe, for example, if you are just taking some reading from your voltage or current, so maybe you have not taken, or if you are just getting some data, or for load forecasting also, if you have missed some type of data at any particular point, so in your Excel sheet, it will be blank. But once you are going to import this data into your MATLAB workspace, MATLAB automatically fill it with a NaN. What is basically NaN? Not a number. It is a IEEE format. And MATLAB automatically fill your missing value with a NaN. And if you are working on some time series data, okay, so it will fill with a NAT, not a time. Okay, NaN and NAT. So once what we can do, we can just import this data into different type of options are available. Like this is originally I have this data into table form, so it will replace with a NaN, and you can just see that these options also. So blank with unimported cell, or you can replace something. So what you can do, I can just click on this green tick. So I want to import my whole data, and this is my data, and in this data I have some missing values also. So diabetes is my table name, and this whole data has been imported into my workspace, but it has some missing values like NaN here. So I cannot just use this particular data to building my machine learning models. Okay, because now I have to prepare this data, because in my data I have some missing values, or maybe I can have some outliers. So what is basically outlier? Out of range values. So what is meaning by out of range values? That for example, if you are working on some type of specific, for example, for load forecasting, and it shows in all the column that in this day power is required only 1000 megawatt. Next day it require 900 megawatt, for example. Okay, but maybe mistakenly it is written sometimes 1 lakh megawatt. So you just can imagine that 1 lakh is not possible. It is a wrong number. So it is an outlier out of data. So this is called the outlier. So how you will deal with this type of missing values in your data, and with the help of MATLAB, how you can just deal with the missing values and this one. So what we have, if you just open again here, clean data. So clean data options is available. But apart from that, if you open the clean data directly, first it will open the import data tool. Then it will open the a import data tool for you. So let me just open the clean data. So clean data, this function was added last year. Okay. Then if you just click on the clean data, first it will open the import tool for you. And from the import tool, whatever the options you have, you can directly generate different type of code, like generate live script. So if I generate this live script, so it will generate automatically live script. And for example, if you want to now want to import the data from 10 different Excel sheets. So what you can do, you can just click here or type here for I equal to 10, and you can change the name of your file. So using this approach, you can import your data from 10 different files also. Okay. So using this one, what I can do, I can just use this one. So if you just this import data tool within this live editor. Okay. So in this task panel, you have these property. Like if you are working on the sometimes, let's just wait some. What you can do, if you have some data into your workspace, so what you can do, you either you can open the clean data, or you can just insert this clean data tool for you. Apart from that, we have this. If you talk about the task, so if you don't want to import your data from the home page of the MATLAB, here we have also the import data. So we can insert this import data into my live script. So for example, I want to clean my data first, and in diabetes table, I have some missing values. So I can select my this diabetes. So what I can do, I for example, I can just specify the variable. Suppose for example, I have some missing value in this column. So MATLAB automatically, once you select your particular column, MATLAB automatically provide some graph to you. Okay, so it will show you the how many missing values you have in your variable. So I have just selected this particular column, and it is showing me that there are 2 missing values in my data. Okay. Further, what you can do, there are 2 options here are available: fill missing values or remove missing values. Okay. Remove, if you select the remove missing values, so what it will happen, it will just delete all the rows in which you have the missing values. So it is not a good idea if suppose you have working on some small data. Okay, so if you are going to remove that particular data, so as a data science engineer, it is not recommended that you always remove that particular rows. So what you can do, just apply some data science technique, and you have to fill that particular value. So let me just select this fill missing values data, and there are different type of methods are available to filling your data. So we can just use some constant value. Okay, then previous values, next value, nearest value. So it is not some hard and fast rule that particular method will work in a particular, depending on your data. Maybe you have to just select sometime you have to select median moving type of method. So maybe you will get some type of good graph. Okay, if you are working on some type of signal, so depending on your data, it will work always. Might be sometimes you can apply some linear interpolation. So what is basically interpolation? If you are going to find some middle values between two values, okay, spline interpolation, if your data is working like a spline interpolation, so depending on this one, you can select any type of method and it will show you this type of method. So now you have the moving windows, you can just apply the center, asymmetric. So whatever the method you are going to apply, it will just selecting the your parameter for this one. Okay, once you are satisfied with your result, what you can do, you can also generate the MATLAB code for this one. So automatic, this is the command to fill your missing data. If you want to learn more about this filling missing data, you can just visit into the documentation, and using these functions also you can just apply your filling missing type of command. So we can open the help documentation of this one. So again, just I want to just recall you, you can import your data into MATLAB without writing any code using the import tool. If you want to clean your data, that we have functions are available. Further, we have the outlier. For example, you have some outlier into this one, so you can also remove the outlier. If you are working some type of signals, maybe you got some voltage signal or and it has some spikes. So what you can do, you can also remove that trend. If you have your signal have some type of trend, you can pre-process the data, smooth the data. So all the pre-processing tools you can just easily use, and parallelly we can also just what we can generate, we can also generate the code for the same. Okay, once your data is ready, for example, I have this data of and it is prepared. I have two type of data here. For example, this is, I've just taken this example to understand the workflow. Maybe you are working on different data type. Okay, so for example, I have this data. Let me just explain you what type of data I have here. Okay, so this data is related to the diabetic or non-diabetic persons, for example. Okay, so these are the features like pregnancy, glucose level of the person, these are the blood pressure, what is the skin thickness, insulin, BMI, or this is diabetic, and age of the person. But this is my response variable. One means that particular person is a diabetic person. 0 means non-diabetic person. Okay, so maybe in this way you have the data like for particular day you have this load forecasting, for particular day this is the load required in particular area. Maybe in the last column you have, okay, you have some type of load characteristic, and maybe you have this is the day, this is the maybe temperature at particular day, and maybe holiday or non-holiday day. So different type of feature you may have, and you have some historical data that on that particular day, and you have the different feature. That particular day is a holiday or some festival, yes, no, or so what is the power required for that one? Okay, so this is, I have taken this example of. So now just tell me, depending on this data, what type of machine learning type? Okay, it is a which category? It is a clustering type of approach, regression, or classification. Just write in the text box depending on my data. Which type of algorithm or which type of data I have? Yes, depends answer this is classification. Okay, because in this data I have input as well as this is my output or response variable I have. But my response variable is a label data like 1010 1010 or but if in your output or response variable you have any real number, so it could be regression. So you have to apply the regression type of approach. So approach is same, okay, but you have to decide and which type of algorithm you are going to use, whether you are going to use the classification type of or regression type of app. And for clustering, we have the option within the live script. Okay. So let me train this one. So this is a class. I have decided that this is a classification. So what I can do, I don't want to use the programming approach. I want to just open the classification regression app. If you are working on regression type, so you can just open the regression, and same approach you are going to just use to build your machine learning model. Let me just open this. This is my classification. In the same way, what you can do, you can just launch here. So whether you are using classification learner or regression, so it will show you the same option here. Okay. So from here, what you can do, you can start a new session. So if you just click here, you can import your data from workspace, or either you can directly import from the file. So let me just click on, because I'm using here right now. So let me just, I have also saved some program onto the MATLAB drive. Maybe so this is my file. I'm going to import. So in first step, once your data is prepared, what you can do, you can import your file either from the workspace or directly from the file into this one. Okay. So you can just click on this, because this data is my prepared data. So directly I can import that particular. Okay. So it will open this new session from the file. Okay. By default, it will show you the your table name. So diabetes, maybe you have multiple table into your workspace. So whatever your clean data, you can just select from this one. Okay. And this is your outcome. MATLAB automatically select your last column as a outcome. Maybe if your response variable you keep apart from the last column, so you can manually select this one, that blood pressure. I want to find out the blood pressure. So you can also select this. This will be my response. So depending on your application, you can select your response variable. Okay. Now there are three type of, if you are working on AI type of application, there are three type of data. One is training data, second is validation data, and third one is testing data. So what you do, suppose you have 1000 of sample of any data. So you are always not going to train all the data. What you do, you can just keep some data for validation. For example, suppose some teacher teaches you, and so from any particular topic or chapter, he always give you some 4 or 5 examples or solve on the board. Okay, but two example or 2 demo keeps for your validation. That can I just ask you that you solve this one. So this is validating that particular, that this training is going in right direction or not. So during the training or during your class, teacher also some cross question. So validation data always take part during the training. Okay, but you keep some test data. Some part you keep for test data. Once your machine learning model is ready, you are going to test your machine learning model depending on your data. So maybe you have suppose separated 10% data for validation, and it will part of your training, and 10% data for testing. So what you can do, if you want to learn more for different type of validation scheme and how prepare data, so there are link is available. So I recommend you can just click on these link also. Now it is a classifications type of approach. Okay, so automatically it will apply by default one algorithm, like tree algorithm. But if you just go to this section under this model, so there are dozens of algorithm are available. Okay, so these are the different type of algorithm are available under this classification learner app. So I don't know that which type of algorithm will be best for my data. So if you are aware or you are expert that you know that fine tree will be work for me, so you can only just select one and you can train your data. Okay, but I even that no expert can tell that this algorithm will be best for my data. So we have to do hit and trial the things. Okay, so but what is the best part of MATLAB, that we can select all quick to train. So if I select this all quick to train, so MATLAB apply all the algorithm which are supported for according to my data. So what I can do, I can select this one and I want to apply all the supported algorithm on my data. Now, right now I am working with some type of small data. I have only 700 sample. But sometimes if you are working on the machine learning, you have the large data sets. So to training your data sets, it takes some time to or maybe if you're working on large data set, it may be take some 1 day. Okay. So what we can do if you are just going to train your data only on a single device, we have the parallel computing toolbox. So if I enable the feature of parallel computing toolbox, so it will enable my all the cores. All the cores means, for example, if you are using 16 core system, so parallelly you can just train 16 algorithm parallelly if you enable this feature. If you are using 8 core system, parallelly you can enable the up all 8 core and you can parallelly train 8 core. It will take little bit time, 1 or 2 seconds, 1 or 2 minutes to launch this one. But right now I don't have the large my data, so I can disable this one and I can just start my training. So right now, one time one algorithm is trained. If I enable, because I have the 4 core system, if I enable this one, so I can train parallelly 4 algorithm because I have the 4 core system. You have the 8 core or 16 core system. So parallelly you can just reduce your training time if you are working on large data sets. So this is that it will provide you depending on your data, the accuracy. By default accuracy, maybe if I apply the tree, so I get the 68.8 accuracy. If I just using this one KNN, so I get the 64.5. So I can say that, and efficient logistic, it provide me the 76. Okay. So I can just say that this actually algorithm working right now by default as is 67 points. So what I can do now, I have different type of option for optimizer. So what I can do, I can just click on this optimizer. So I can optimize the things because I need to just 76. I need to just increase this 76% accuracy. Okay. So by default, it has used the Bayesian optimization. So what I can do, I can just select the grid search, then I can retrain it, then I can just select this random search. So depending on different algorithm will be work for my this one. These are the iterations that I can increase the iterations. And I will just notice that if my accuracy is increasing or decreasing. So there is different type of options are available. So efficient logistic, and I can just, if I type here efficient logistic, so there are different type of algorithm are also available under this one. That if we talk about this decision tree, so I have the optimization decision tree, so I can select this one. So by this one way of increasing your accuracy is the optimization. Okay. Second is that if you are going to click on this feature selection, because I've just used all the features, but sometimes some features are not good to during your training. For example, if we talk about the some for example, the like employee ID or student roll number. So maybe, or if we talk about this diabetic or non-diabetic person, maybe if there is some name of the person is available, name of the person. So it doesn't mean that if the name of the person is that A or B or C. So name is not an important feature that it will just increase the diabetic or non-diabetic. So sometimes if you have a lot of data, so you need to just avoid the things. So how you will just find out that which particular feature is important for my data. So what I have here, I have different type of algorithm. So if I apply here MR algorithm, this is minimum redundancy, maximum algorithm is available. So using this one, I can just get a graph. So this graph will provide me that which is the important feature for this training. So this feature one, what is that number one here? Glucose. So glucose level is a important feature, and it will play a wide role for diabetic or non-diabetic persons. So what is the least feature? This is maybe my blood pressure. So blood pressure is a least feature. It doesn't mean it's, if a person has low blood pressure or high blood pressure, that means it may be diabetic or non-diabetic. So what I can do if I'm working on the large data set, so what I can do, I can just apply and reduce my feature. So I have selected the 7 feature only. And what I can do, I can again retrain this model in this way. Okay, I can retrain this model and maybe some accuracy will be reduced for this one. So there are different type of methods are available to optimize. Optimization is available. You can reduce your feature, that hyperparameter tuning. What is hyperparameter tuning? That for what parameter your algorithm or your model is trained in accurately. Okay, then we have this generate functions. So once you are satisfied, what you can do, you can generate a MATLAB functions for that. So that what we can do, it will generate a MATLAB code for you, and that MATLAB code you can use for to further if generate that particular code. And what you can do, you can just export that particular model into workspace if you want to. Suppose I rename it as a train model. So there are different type of graphs options are available if you want to plot the scatter plot or some confusion matrix. Okay, confusion matrix. So by just clicking on that, you can also just for if you want to just publish your paper, so you can just draw different type of graphs. So once you're ready, that you can export that particular model, or you can generate the function for that. Okay, so I have exported my my machine learning model into my workspace, and this is my workspace is available, and I have named it as a TM model, like TM. This is my machine learning model. So if I type my variable name here, it will show me this one. Okay, this is my machine learning model. So what I can do now, if I pass new data to this one, so how you will predict that there is a predict function. So in this TM is my machine learning model name, and here I have the different type of functions are available, or field are available, because it is a structure type. And in this structure, I have one field is predict function, second field is required. So you have to always pass 1 cross 8, because if you have the new data means, for example, in this data I have 9 column, but the 9 column is my response variable. But if you will pass some new data to this one, for example, next day some samples comes from the patients, so you will have only 8 column from each patients. So how you will predict? Then this is your machine learning model is TM. So you can just give the name of your model TM, and you can call the first field. What is my first field? Predict function. So this is my first field, and in the round bracket, if you have the new data with you, you can pass your new data, new table, and it could be any number of rows, but column always will be 8 here. So it will provide you the response depending of your accuracy. Suppose right now we have the 76 accuracy. So what we can do, we can just, let me just try you if I can just, because right now I am working on online MATLAB. So I can, what I can do, I can import some data from So what I can do, I can just open it. I can change the. What I can do, I can just select only first column from this. It's not providing. What I can do, I can just click a, I can copy only first column and I can create some new data, and from that new data I can delete some type of this last column. If I pass here this new data without my ninth column, so it will provide me the just graphic. So you will do all the things that whatever I have just used in the MATLAB on RAM. So now I hope that you understand that how you are going to build your machine learning model. So first step is to building your machine learning model. You're going to import your data, and what are the functions are available within the MATLAB. Using the import tool, you can import easily your data. Okay. And second step is to pre-process your data, and what are the functions are available. We have the clean data tool, and or either you can just use the live script options, and within the live script option you can insert the clean data task to clean your data. Okay, once your data is clean, then depending on your type of application, whether you are working on regression type or classification type, so what you can do, you can just use the classification learner app or regression, and you can import your data, you can train your data, and whatever the maximum percentage you are getting accuracy. Okay, so if you are going to work in regression type, it will show you the not percentage, it will show you the error. So what is the error you are getting, less error you can select on that one. And in the same way, using that one also, you can generate the code, or either you can export your model into MATLAB workspace, and you can feed your new data using the name of your model dot predict function, and within the round bracket you can just feed your right new data. So it will predict depending on your this one. Okay. And for clustering type of approach, you can just use this one. And for example, if you want to just learn more on these type of algorithms, so for example, k-means. So there are a k-means algorithm are available. If you want to use the command line approach or function type, so we can just use this one, k-means. So we will pass our data and we can divide different type of clusters. So if you want to understand more on this one, so some data reference data is given to you. You can apply that 2 clustering or 3 clustering, and there are some algorithms available. So that you can decide that in your data 2 cluster is good or 3 cluster or 4 cluster is good. So depending on this application, you can select this one also. Okay. So this is that just how you can easily build your machine learning model for predictions also with the MATLAB. So before just moving to the machine or deep learning part, let me just know you that if you have any query, we can just move to the deep learning part. Okay. So just I told you the deep learning is a type of machine learning, but here what is the difference here? Model learns to perform classification task directly. That means it find out the features from my data. It could be your image, if you are working on the image file, text file, or sound file. Okay. So deep learning is usually implemented using a neural network. Okay, so what is meaning by deep here? Generally in the neural network, we have some limited number of hidden layer, but in the deep neural network, we have number of more layers. Okay, so this is called deep neural network. So what is the basically when you use machine learning or deep learning? So these are not hard and fast rule, but depending on this one, if you are just working on some small data set, so you can just prefer this deep learning. If you are working with large data sets, so we can prefer deep learning. And further, choose your own feature. If you have your own feature with you, so it is best that we can just use the machine learning. If you don't have your own feature and it is not easy to extract the features, so what we can do, we can just use the deep learning. Further, we have the of classifier available many, and here classifiers are few. Training time, if your training time is short, so you can just use for machine learning, and if your training side time is very large, so we have this, we can use this one. Okay, so as you know, if you want to use the this deep learning, so we have the lot of data or label data is available. So we can just take that label data from the different sites also available. And nowadays we have the GPU acceleration, that we have the good hardware with us. So you have that some type of NVIDIA enabled systems. And what is the third thing that it make popular deep learning? There are different type of world-class pre-trained models are available. Like if we talk about the AlexNet, VGG16, and RNS50. So there are different type of pre-trained models are available. Pre-trained models means some different company already trained that model. Okay, they have prepared the model, and what we can do, we can just utilize these model for my image classification or my data classifications. And what is ONX converter? This is a open neural network converter. If somebody is working on different platform, for example, Python or PyTorch or Cafe, different type of platform, and you want to import that particular model into MATLAB, and if you are working on MATLAB model in the deep learning and you want to export MATLAB model to other platforms, so it also possible that we can just export import any type of platform model for that one. Okay. So deep learning also versatile. Again, we can just use it for object detection. Okay. Semantic segmentation, if you want to denoise speech using a deep learning network. Okay. So for example, if you want to just classify your different type of machines, or if you want to work on some type of, for example, working condition machine and some type of non-working machine, that particular machine is going to under maintenance. Classify ECG signal, classify the image. So depending on your applications area, you can also classify the different type of image. And further, we can use this deep learning for time series data also. So in the next section, we will also see that one type of approach. This is called the LSTM algorithm. So these are the applications area. Now we will see that how this CNN works. Basically, CNN, how generally we pass my image data to this convolution layer. Okay, so basically CNN is a convolutional neural network. It is made up of various layers. So I pass my data to the initial layer. So we will see that what are the different layers are available. So initial layer find out some low level feature, okay, from my image. But these feature again pass to the next layers, and some middle layer find out some high level features. Again, these feature feed to the next layer, and my end layer find out some high level features, that it like shapes, what is the, it is flower, it is showing me the category. And finally, these are the fully connected layer or classification layer I have. And depending on the feature, because this CNN already trained on lakhs or millions of images. So basically, once I pass my images, it extract the feature from my image. And because in the database, like in the one type of database, it match that feature and it classify that it is my flower image. Okay. So we can start our deep learning application with few line of codes. For example, just try to understand this. That I told you there are different type of pre-trained models are available. World-class pre-trained model. It is not made, for example, it is not made by the MathWorks. Some trained model are developed by the Google, Facebook, different companies. Okay. So what you can do, you can access all the pre-trained models. So you can just see the list in the MATLAB documentation. So all the popular model that you can directly access into MATLAB. Okay. So let me just show you that how you can access these model into MATLAB. So first thing, what you need to do? So first you decide that which type of algorithm or pre-trained model you are going to use. So what you can do, you can just visit on this get add-ons. Okay. So just click on this get add-ons, and you are aware that if you want to use some type of hardware with the MATLAB or Simulink, we need to install the support package. For that also, we need to install the support package for any pre-trained models. Okay. So by default, it not comes with your software, because if MathWorks already just install all the support packages, which is maybe not required for your, so your software size will be up to 60 GB. So whatever you require, what you can do, you have the license version of MATLAB, you can just visit on this add-on explorer, and whatever the support package you require, you can just install. For example, I want to install the support package for AlexNet. So AlexNet is a pre-trained network. AlexNet is a pre-trained network which is trained on millions of images. Okay, so you can just visit here and it will show you the option that add install. So I have already installed, so it is showing me the installed. Okay, you can also read about the what is basically AlexNet. So on AlexNet, there are maybe one IEEE paper is published, so you can just visit. There is another popular pre-trained network is GoogleNet, RNAS50, YOLO, which could be used differently for your object detections, and it use the features of your computer vision as well as for your deep learning. Okay, so there are different type of network are available. Once you install the support package, what you can do, you can directly type the name of that particular network, like AlexNet, GoogleNet, ResNet 50. Once you install the support package, and let's say I can save it into a variable of net. So once it is, so net is my AlexNet. So what I can do, I can just double click on this one and I can see what are the layer, different types. So it is a 25 layer network. So first layer is image input layer. Second layer is convolution. Convolution means it applies some convolution operations on my input image. Here ReLU layer, what is ReLU means? Rectify linear unit. If some negative value comes from the convolution layer, it convert automatically to the positive values or zero value. Okay. Cross channel normalization. So whatever the output is coming, it normalize my data. Then maximum polling layer. So again, it desample my data so that I can select only the some high level features. ReLU layer, then again maximum layer, ReLU layer. This is the network. It is working in the background. Basically, what are working? Some mathematical operation is working there. These are the fully connected layer where all the nodes are connected. Further, I have the dropout layers that I can drop out the things. Then again, I have the fully connected layer. So whatever the output is coming, that all will be connected on this, and this is my softmax layer. and this is my classification layer. So it will classify the thing, and softmax layer actually it will create one type of table for you. Okay, so depending on probability. So for example, if I pass one cat image to my CNN, so it will find out the feature from that cat image. Okay, because cat have some specific color, maybe some from the ear or eyes, but maybe the some feature from the cat, maybe it confused that 0.1% or 1% feature, maybe it can match to the dog, or 5% feature it can match to the lion. Okay, so how this classification layer classify that this is a cat image? So because in this softmax layer, all the data will be saved in the form of some type of point, like it is a chance of 0.92. That means 92% chance it is a cat. Okay, then 1% chance it is a lion, 0.5% chance it is a dog. So softmax layer decide that okay, classification layer will decide that 92% chance is cat. So it will show you that this is cat. Okay, so these are the layer, how these layer works for that. Now what I can do, I can load an image. So I can read an image of IM read, and let me just say, you can also read different type of image depending on your application. And this is my image, and I can save into IM variable. Okay. So this is the image. I can show this image IM. So this is my image. I want to classify this image. I want to pass this image through this network. Okay, so this is my image. But what is the problem, that my image size is 7921056 into 3. That means it is a colored image. But this network can accept the size of this image. If I talk about the input layer, so it can accept the size of this image, 227 cross 3. Okay, so I need to convert my image size into this size, because I cannot pass. So what I can do, I can resize my image. Okay, IM resize, and which I want to resize the IM image, and what is the size I want to convert, 227, and this is my new image. So IM1, I can say this is IM1 image. Okay, so using this I can resize my image. So once you are going to just do your MATLAB on-ramp courses, so there may be image augmentation command you will find, image augmentation. So because right now I am using only single file. So I will apply only IM resize command. But if you have the folder of images, you can use the image augmentation file. And right now I am using only IM read function to read a single image. But if you want to import folder of images, that means you have 10 folder, and each folder you have the 100 images. So you will find out during your on-ramp courses image database. So you will create the image database. So there are two differences. We are working on the single image or folder of images. Just remember these two inbuilt function, why we are using the image data base or image augmentation. So right now I can show my this image IM show, and this is my IM1. Maybe some pictures is came, size is reduced. So how you can classify? How you can classify your image? Just apply the classify command. And what is my network name here? AlexNet net. I have saved it into net variable, and I want to pass a image 1. So it will take little bit time, and it will classify the thing. Okay, good. So it's tell me that this is a peacock image. So basically what is happening here? What is happening? I have just passed a peacock image into this AlexNet, and because in this AlexNet already Let me just show you that what type of object, and this is my, if I just go to the classifications, and these are the hundreds type of object in cat, different type of coat, electric ray, ostrich. So these type of images already trained. So they trained, like they have taken the ostrich image, maybe quantity they have taken the 1000 ostrich images from different type of uh, robin, bulbul, different type of images they have already trained, and it will automatically finding the feature from my images, and it say that this is the class of your images. So this type of application I can use to classifications of any type of object. Okay, but there are maybe two questions here. Okay, let me just discuss one by one. For example, what you can do, you can just use this example for your live image classifications. Okay, so right now I've just show you that how you can use this example for your live image classification. For example, you need to connect some type of camera with the MATLAB. Okay, but this will work that if you are using some high definition camera, or your algorithm is good. But let me just show you that how we can just use this type of example for live image application. So right now what I will do, I will use my camera. So as you know, we can connect my camera with the MATLAB easily. So webcam also I can use. So using the webcam command, webcam. Okay, so before just if you want to use your webcam, you need to install the support package for your webcam. So just go here and just install the first support package for your webcam. So once you install the support package of your webcam, you can type the webcam command. So it will open a webcam through MATLAB. Okay, so let me just open this example and just understand the things. Then what we are doing here, clear all is not good, so clear only. Okay, so here what we can do, what is happening here, AlexNet. In the first command I am using the AlexNet, so I'm loading the AlexNet into my nnet. I can give the any variable name. And if you want to use the IP camera, so if you want to connect some IP camera with your MATLAB, so what you can do, you can type the IP camera. Okay, and IP of your camera directly here. Let's just enable this one. Okay, and again you need to install the support package for your IP camera. And how you can start your webcam here, using the webcam command. And I can save this object into a cam variable. Okay, now what I'm applying here, I'm applying a infinite loop. Okay, then whatever the cams in my cam, I can also take the snapshot from camera using the snapshot command. So cam dot snapshot. So that particular image will save into a SS variable. Okay. Now what I can do, because I'm going to pass this image to my AlexNet, and what is my AlexNet is nnet. But first I need to convert this snapshot size into 227. So I have passed this image with this size. Now I can just draw the picture and I can provide the title also. So what I'm doing, I'm just going to run this program, and you will see that my cam will be open, and it will show the some live. So if just let me show you, let me just increase the size. So it is showing like I have in the background my LED available. So it is showing some monitor or this one. Okay. So if I just bring my bottle here, so maybe properly it will show me the some type of knee pad or something. But it is confusing because I'm not using the some type of camera. But like this, it is showing the home theater, looking some theater type. Okay, maybe sometime it will show you the barber shop, it will show you some type of glass. So in this way, what you can do, you can just So what I can do, I can just clear the object. So in this type, how you can just utilize your algorithm for live image classifications. Okay, so just see the workflow, and as you know, you can just connect your camera and the same algorithm you can just utilize to classifications of your object. Okay, so this is deep learning that I've just shown you one example, and further maybe one question from your side. Okay, so suppose you are working on some new data. For example, we take, if you are some mostly are from the electrical background and you want to make some type of applications using the deep learning, that I want to classify my different type of instrument. Okay, maybe if somebody with the camera, like it is a voltmeter. Okay, maybe it is a punches or different type of electrical system, or if you are working on different type of PLCs, so it can also find out that this is the PLC of, or different type of motor images can find out. So what you can do, you have to just bring the, or you have to make the folders of different type of images. Okay, suppose in one folder you will keep all the type of motors, or maybe servo motors. In one folder you will keep the different type of your voltmeter or different type of devices. So if you pass that images into this AlexNet, it will not classify your image. Okay, because maybe your data is new. So how you can just classify your new data with any pre-trained model? So now you have two options. What options you have? If you are expert, you can make, or you can draw some type of deep learning model from scratch. One method is that. Okay, and second method is transfer learning. What is meaning by transfer learning? That suppose I'm not expert and I don't want to just make some type of model from scratch. So what I can do, I can use transfer learning. Transfer learning means I can just utilize the layers of previous trained network, and I will retrain that network for my images. For example, let me just open one example here. So to building your network, there are command also available, but in the app I told you, I have this deep network designer app is available. So with the help of deep network designer, I can build any type of network graphically, or whether you can import any pre-trained network into this one to analyze the layer of each network of that particular network. So this is a deep network designer. I told you that there is commands also available for apply each type of your convolution layer or ReLU layer. Functions are available. Okay, so what I can do, I can just have the option. I can open a blank network, or I can also import from the workspace. So in this example, what I'm doing here, I'm just using right now AlexNet. So let me just, sorry, GoogleNet. So GoogleNet, it is another network like AlexNet. So you need to install the support package for this one, and it is large network compared to the AlexNet. It has a 144 layers. So right now I am using going to load this GoogleNet, and it is, if I just go to my workspace, now this AlexNet with the name of net is my workspace. I can open it, or what I can do, I can import my network from the workspace. And what is the network in my workspace? This is a net like Google Net. So I can open it. So what I can do, I can close this one. Okay, so now the Google Net has been imported into this one. Suppose if you want to make your own network, what you can do, we have the libraries available. So what you can do, you can just put the any layer from here, you can connect these layer and parallelly you can feed the parameters. So without writing the code also, you can just make your own network from this one. Let me just zoom in. What I can do, I need to delete this one. Okay, what I can do, I can just zoom in so that I can just properly see this. So in this app, whether I can design my network from the scratch with the help of these library, or I can import any pre-trained network and I can analyze the layer of this one. So I have imported my Google Net, and Google Net is a 144 layers and number of connection is 170. So first layer, if I want to steal the first layer, this is the name of the layer, and the size it will accept as a 2 to 4 class cross 3. Okay, this is my second layer, or this one. So now what I have, actually I have some new data with me. So what is my new data I have? So if I just click on this merchant data, so in this data I have some new data for me. Suppose in this, let me open this my outside the MATLAB. So I have actually 5 folder here, and all the my image are new. So this is a cap image. So in the MathWorks cap image, I have all the hats are available. And in the second folder, I have suppose playing cards. So in this, in this image, I have the playing cards. So like this, you can also have different type of devices if you are using in which. So what I want to do, if I will pass these playing card or this type of head to Google Net or AlexNet, maybe it will not find out. Okay, or it will not classify. So what I need to do, I will use the transfer learning. What is meaning by transfer learning? I am not going to make any network from the scratch, because I don't have the much knowledge that how many layer I will just use this only for this one. So what I can do, I only just replace only 2 layer of this network. What are the 2 layer? Fully connected layer. So I will delete this fully connected layer, and I will replace a new fully connected layer, because this network is already trained for millions of images, but I am just going to retrain this only my 5 folder. Each folder I have the 45 images, or I will train it only 250 images. And this classification layer can categorize into 1000 of them. But I have only 5 category. If you have the 7 category type of image, you can just, so this is my classification image, classification layer. So I only replace 2 layer, fully connected layer and classifications, because I need to, and it is auto. So now what I can do, I can just click on analyze. One more thing, what I can do, because in the fully connected layer, I can just feed the parameter. For example, because it is a already trained network, so some parameter what I can do. So 0 error is available here. Okay. So what I can do, if I just click here, so I can rename it is anything, like output size is, this is my, I can say it is a 5. And what I can do, weight learning factor, I can increase this bias learning factor, because it is already trained. So I can just retrain it more fastly. So now what I can do, I can just export, I can also generate the code, or I can export this trained network into workspace. exporting. So it has been exported with the name of lgraph_1. Okay. So now in this example, what I have, now I'm going to load my data. So what is the data I have? So using this one, just see here. So if you have your data into zip folder, so you can unzip your folder using this one. And now I'm going to create a image data store, because right now I have a merchant data folder, and I'm going to insert enable some option that includes the folder as a true. That means whatever my folder name, it will be my label name. And what I can do, I can split my data, whole data, 70% for training and 30% for validation. Okay. Now, because my Google Net will accept only this size 2 to 4. So what I can do, I can resize my image according to this network. Okay. And both type of image. It is, I have converted for training data set, which is 70%, and this is for 30% validation. Okay. So now what I can do, I can just click on this one. I can load my data into workspace. Now these are the training option. First, I need to train this one. So using this one also, I can train my network. Like this is algorithm I'm going to use. These are the many base size. So I will pass 10 image at a one time, and this is other method that I'm going to use. If you want to learn more on the training option, what you can do, you can open that again documentation, and you can just find out what are the different type of options I can provide here. So let me just divide it into section, and it's better that I can run only this section. So how the training is going on, you can just play here, just run it, and now you are going to retrain this network for your images if you have your new images from the scratch. So here we are not going to just try to understand that we cannot, for example, if I require some car, okay, so I will not just research and I will develop my company and I've just developed some new car. What I will do, I will just purchase, I will pay and purchase the car, okay, or modify. If I have some, I can purchase the old car and I can modify depending on this one. So I'm not going to just develop this network from scratch. I am just utilizing the pre-trained network, but for my images. Okay. Now, after the training option, what you can do, you can train the network. So these are my option, and you can train that particular network. Maybe some missing data. So it will train and it will save into this one. But if you don't want to use again this programming type approach, what you can do, we have this data options available here. So what you can do, you can just load your data from your folder. Then we have so from here you can load your images, and from here what you can do, you can just apply the training options. So different type of training options you can just apply here, and you can start your training here. Okay. So once your training is completed, your network will be ready. You can save this network with any name. And next time, if you are going to pass your new image with this network, so it will definitely classify your image. Okay. So this is called the transfer learning. If you have working on some new data type, and you can just utilize any pre-trained network, AlexNet, GoogleNet, you can edit the layer and you can utilize for your image classifications. So if you want to just label, suppose you want to label, you have some data, and how you will prepare the label for your data for different type of applications. So we have these image labeler apps also available. So with the help of these labeler app, we can just, and using this deep network designer, you can quickly build your network if you want to design your own network.